Welcome back. It is now time for us to do some exercises and problem solving using the second law of thermodynamics. Before we actually do that, an exercise set is already available to you. We should remember a few things. There are a few tricks of the trade and some procedures which we will follow. Of course, the procedures which we have followed for evaluating work and problem solving using the 0th law and the first law of thermodynamics, those procedures will remain. We are not going to keep them away. They are also part of thermodynamics. So one thing to remember is we should not forget the first law and the 0th law. We will use them as needed. Also, the equations of state will be required to be used as needed. Then we will have to do the following. Remember that second law, the basic expression of second law has two terms, delta S and dq by t, integral of dq by t. So we will need to determine or obtain an appropriate value for delta S for the systems and processes involved in that situation. Here we may use an expression, or here we may use tables. If it is steam, expression is appropriate for simple systems like an ideal gas, whereas tables are appropriate for a situation where you have water and steam. Then we will have to evaluate integral dq by t for the systems and processes involved, if possible. If not possible, we will see there are some escape routes. Then after that, we should always check whether the second law is satisfied. That means either check that delta S is greater than or equal to integral dq by t, or compute the entropy produced, and then Sp should be greater than or equal to 0. Okay. And after that, we should comment, provide a comment or comments. For example, if it turns out that the inequality as specified in the second law is satisfied, then we will say that it is a real irreversible process. And we should also be able to guess or say something about what causes this irreversibility. If we notice that the second law is satisfied in its equality form, then this implies that we have a reversible process. And we know from our experience, everybody knows from their experience, that a reversible process is very, very improbable. So it is a thermodynamic ideal. In real life, we hardly ever see any reversible process taking place. And if we find that between this it is not satisfied, but it is the other way it is satisfied, we will say that this is an impossible process. And if it turns out to be an impossible process, we should say that, look, what is it that is making it impossible, and if something is possible to do which would make it irreversible and possible, we should be able to provide hints or suggestions for that. Thank you.